An input-output table is shown below. Determine the rule required to get from each input to its corresponding output. So we have first 400,000 as the input and 80 as its corresponding output. 10,000 and 2, 5 million and 1,000, and 200,000 and 40. Doesn't look like we're adding or subtracting or multiplying by the same number. It looks like we're dividing by the same number. So let's put the division sign next to each of these. And let's try to look at our input and output values. We have, say, 40 and 8. What would I divide 40 by to get to 8? 5. Okay, would I divide 10 by 5 to get 2? Yes. What about 5 to get to 1? Yes. So it's going to be either 5, 50, 500, or 5,000. So since this 5 times 8 gives me 40, it takes care of these two this 0 right after the 4 for 40. And then we have 1, 2, 3, 4 zeros left. So, but we want 1 0 remaining in our final answer. So let's see if 50 would work. Well, that would get rid of these 2 zeros would cancel out. You would have a lot more. Let's try 500. This would cancel out with this one. You would have 8 and then 2 zeros. Okay, that would be 800, not 80. Let's try 5,000. So if you did 400,000 divided by 5,000, these zeros would all cancel out, and then you would be left with 40 divided by 5, which is 8, and the extra 0 that corresponds to this one right here. So that indeed does work. So it looks like 5,000 is going to be the number. Let's look at 10,000. Is 10,000 divided by 5,000 too? Yes, it is. What about 5 million? Is 5 million divided by 5,000 1,000? Let's write that one out to see if it works. 5 million divided by 5,000. Okay, so this set of zeros goes away, these go away, these go away. And then we would have 5 divided by 5, which is 1, and then 3 zeros remaining. And yes, we would get 1,000 if we divide 5 million by 5,000. And then 200,000 divided by 5,000, we would have 1, 2, 3. And then 200 divided by 5 would be 40. So in each of these cases, we divided by 5,000. So that's going to be the rule used to get from each input to its output. Divide by 5,000, or answer choice A.